Hi, everyone, and welcome to the first session of the day of our Oil and Gas Academy internship program. My name is Nihal Munir, and I'll be your moderator for the day. As always, please keep your questions in the Q&A part of Zoom and on YouTube Live. Also, keep the questions only related to the technical content of the presentation. Any administrative questions, please keep those to the Facebook group. And don't worry about the attendance. As always, we are recording everything. So we have a very exciting lecture for today. And let me introduce our speaker. Our speaker for the day is Engineer Ahmed Mansour. Engineer Ahmed is a drilling and cement engineer at BG Services in Permian Basin, USA. He is also a PhD candidate in Texas Tech University, Petroleum Engineering. He graduated from Texas Tech with master's degree and a bachelor's degree from the University of Shirabali in petroleum engineering major. Engineer Ahmed, thank you so much for joining us today, and over to you.
Thank you, Nihal, for the introduction. Good morning or good afternoon for everyone. And thank you for giving me the chance to participate in this great program to share my knowledge and experience with the future petroleum engineer in Middle East. So my presentation today is going to be about introduction to well cementing. In this presentation, I'm going to go I'm gonna cover like the basic fundamental knowledge about the cement. I will start first with the outline, which is the introduction. I will give introduction about the cement, why we bump cement, and then I'm gonna move on to the primary cement job, which is conductor, surface, intermediate, and production. And then I'm gonna move on to the casing equipment, what kind of equipment that we need to be familiar with for a cement job. And then I'm gonna move on to the cement job process, how we do a cement job, and then what kind of cement lab testing we run at the lab, which is one of the most important topic in cement. And after that, I'm gonna move on to the cement additive, why we need to add chemical additive to the cement, and how this is gonna affect on the property of the cement. And then I'm going to end up my presentation with the bulk plant where we blend the cement and cement surface equipment, what kind of cement we expect to see at the location. So for introduction, why we do cement? This is a good question. Why we bother ourselves and bump cement between the casing and between the formation? Why we don't just run the casing and start producing? As some of you know, or all of you know, that whenever we start drilling, we encounter at the shallow depth fresh water. And then we encounter shale formation, and sometimes, or all the time, we encounter the oil zone, and then sometimes salt water or the aquifer. By bumping the cement, we're going to be able to isolate the salt water from contaminate or to contact with the fresh water. As well, we're going to be able to prevent any contamination between the oil zone and the fresh water. So poor or non-existing cement could allow salt water oil to travel along the casing and contaminating the freshwater bearing formation. So here's some of the purpose of bumping cement in oil well. As I mentioned in the previous slide, provide zonal isolation to prevent any contamination for freshwater in the area or any connection or contact between different zone in the well. Another thing, to provide axle load for casing, as well to protect the casing from corrosion. Whenever we bump the cement, we're going to be able to isolate the casing from contact with any kind of fluid in the formation. This will prevent any corrosion in the future. Another thing is support the borehole. If you are dealing with unconsolidated formation, abandon the well. After a certain time of production, some operator company, they decide to shut down the well because it's not economic anymore. So what they do to abandon the well, they bump cement inside the casing in different depth and different volume. And after that, they shut down the well. Well repair, if we have a problem, for example, if we have corrosion in the casing, one of the way to fix the corrosion is doing a squeeze job. I'm going to cover it later a little bit about it. So, what is the zonal isolation? According to Eric Nelson in his Well Cementing Second Edition book, he mentioned that a durable hydraulic seal in the well bore that allows selective fluid production from subsurface formations and prevent leak into other formation or to the surface. In other words, it's allow us to produce from certain depth at the certain zone, and as well to prevent having like liquid of the formation to reach the surface. This is a video show a bad semen job. As you can see here, at the top of the well, we see water and we see bubble. That indication that we had bad semen job, and there is communication between the bottom zone of water aquifer and the surface. And we don't like to see this because this is could lead to environmental problem. Another thing about bad semen job, as we all know about Deepwater Horizon in Gulf of Mexico, one of the result of this disaster is the semen did not set. So since the semen did not set, we accept cake or blowout, and this is lead to one of the most crisis in the oil industry, which is Gulf of Mexico. So one mistake in cement could lead to this crisis. So now let's move on to the second topic, which is the primary cementing. In the primary cementing here, I'm gonna cover the conductor, cement job, surface, intermediate, and production. About drilling liner and production liner, I'm not gonna go through it. And multi-stage, I will cover a little bit later. So conductor casing, usually it's from 40 feet to 1500 feet. The average depth for the conductor casing is around 200 feet. The size from 20 to 36. The main purpose of doing conductor cement is to prevent any washout under the rig. Sometimes when we start drilling without conductor, the rig could collapse or there is washout under the rig, and this is the problem. So that's why we do conductor and do cement for the conductor. Usually we use like Class C cement without any chemical additive. So it's a cheap cement job. Another type of cement job is surface cement job, usually from 100 to 1500. The surface casing usually from 100 feet to 5500 feet deep. The size from 758 to 20 inch. The average size that I deal with usually 1338. Why we do cement for surface casing? It's to protect freshwater sand. It's very important for a surface job to have cement reach to the surface and isolate the whole area or zone of the freshwater, because if we don't do this, we might end up with contamination for fresh water that we drink in the area that we drill the well at. As well to provide a place to mount the BOB, uh, to uh, 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 to support unconsolidated formation and for lost circulation zone to sell it. And I see now recently we start doing offline cement job. This is a good topic that you should be familiar with, which we pump cement without having rig on the well. So in the United States now, they have like a well bed that has 5 wells. The rig is gonna start drilling the surface string for first well, and then they're gonna skid to the second well. And after that, the cement crew is gonna come over and pump the first well surface string without having rig on the top of the well. And it's go like that. After that, the rig gonna move to the well number 3, and the cement crew gonna go to well number 2 and pump the cement. By doing that, we're gonna save a lot of rig time, which around 10 hours rig time. So we are talking about around $25,000 per well. So this is a simple video show how we drill for those who not like familiar with the drilling and cement process. As you can see here, we have a conductor. Now we're drilling the surface. And after we drill, we trip out, and now we're running the casing. And here we have the mud drilling, and here we bump the spacer, and this is the bottom plug, and then we bumping the cement. we bumping cement from inside of the casing to the annulus. And after that, we follow with the cement with the top plug. And then we start the displacement. Here we displace the old cement inside the casing toward the annulus. This is for surface casing. Now let's move on to the intermediate. Intermediate, it's a string that has average size from 658 to 20 inch. 958 is the most common size that we use. The depth is from 4,000 to 16,000 feet. So we're dealing with high temperature pressure area. Why we do cement for intermediate? For many reasons. For example, if you have salt zone area, you need to have cement so you prevent any corrosion in future for the casing. If you're dealing with high pressure zone, you would like to isolate that zone with the cement. If you have lost circulation zone, you're gonna bump cement to isolate that lost circulation zone, as well to support later casing string, which is the production. Here it show how we drill the intermediate. After we drill the surface, as you can see here, we start drilling inside the casing, surface casing, and drill out inside the cement as well. And then after we finish drilling the open hole section, we trip out the drill string and we're running the casing. It's similar to the previous, to the surface cement job. And then we bump the spacer. After that, we drop the bottom plug and then bumping the cement. And after that, we bump the top plug and start displacement, as you can see here. The last casing type that I'm gonna cover here is the production casing. We call it critical job because one mistake is gonna cause a lot of issue. Usually the depth for the production job from 1,700 to 20,000 feet, and the maximum depth that I work with is 23,000 feet. The average size from 5.5 inch to 5.5 and sometimes 7 inch. I didn't see 20 inch before. The main purpose of the cement and production job to complete the well for fracking in future, to provide pressure control for the production zone, and to well control when perforating. So now let's move on to the third topic, which is the terminology or cement equipment that we need to familiar with. Here I'm gonna cover only those who related to cement. I'm gonna cover the plug drop, the plug, top plug and bottom plug later. Cement manifold, I have another slide for it. So here I will start with float collar. The float collar here, it's a valve that allows cement to go through it. It's one-way valve to allow the cement and not allow cement to return inside the casing after we bump it. We have another float shoe here. It's also to allow the cement to go through it and not going back inside the casing. And usually we use a float shoe as well to guide the casing inside the well. We have guide shoe. It's also to guide the casing inside the well. The difference between guide shoe and float shoe, the float shoe has a valve, the guide shoe doesn't have valve. We have centralizer. The main purpose of centralizer to set the casing in the center of the well. So we have a uniform cement around the casing. It's very important to have centralizer. Scratches here, we use it to remove and clean the well bore. By using scratcher, we're gonna get rid of all the mud cake. So whenever we start pumping the cement, we're gonna have good bonding between the cement and the formation. Cement basket, it's option, not necessary. We use it to support the cement. So whenever we start pumping the cement in the annulus, the cement basket's gonna help us to reduce the hydrostatic pressure. I believe that's all for cement terminology number one. So now let's move on to cement terminology number two. I believe you are familiar with the mud, which is the drilling mud that we use to drill. Spacer, Spacer, it's depends. Sometimes we use fresh water and sometimes chemical spacer. The main purpose of the spacer is to prevent any contact between the mud, drilling mud, and between the cement. Because if we have any contamination between the mud and the cement, we might end up with changing the property of the cement. Lead slurry and tail slurry. Usually, whenever we do cement job, we have something called lead and something called tail. The lead is going to cover the up part of the annulus. The tail is going to cover the bottom part of the annulus. Usually, the tail has higher density than the lead. You may ask why we're using lead and tail. For many reasons. The first reason, uh, since since the lead has less density than the tail, so this is gonna reduce the cost of the cement job. Another thing, to reduce the hydrostatic pressure, if I'm gonna use the tail for the whole well, the hydrostatic pressure is gonna be too high. So that's why we introduce lead slurry with less density, so we're gonna end up with less hydrostatic pressure. By reducing the hydrostatic pressure, we not get frag deformation. Displacement fluid, it's the fluid that we use to displace the cement from the inside of the casing toward the annulus. Float color already mentioned. Float shoe and guide shoe already talked about it. Shoe track. Shoe track is the area between the float collar and float shoe or the guide shoe. So here, I'm going to talk about the guide shoe. The guide shoe, as you see here, this is the guide shoe. It's run on the bottom of the casing, used to guide the casing into the hole. Um, Usually it has hole in the center, allow the fluid to move in it, and no valve device in it. This is one of the questions in the quiz, so make sure to understand what the difference between the float shoe and the float collar. And here the float shoe, as you can see here, the float shoe, it's similar to the guide shoe, but it has valve here. It's one-way valve, allow the cement to go in it, but not return. We have float collar. Float collar is a valve that we set one or two joint above the float shoe or the guide shoe. It's a valve that allows the cement to go through it in one way and not allow cement to return to the casing. And the shoe track, or what's called shoe joint, is the area between the shoe and the collar. Usually from 40 to 80 feet, and sometimes it's different based in the design that the company or the operator company use. Centralizer. As I mentioned, centralizer is very important for cement job. As you can see here, this is a result of cement job that we did not use centralizer. You can see here we have cement in this area, but we don't have cement at the bottom here because the casing has not been set at the center of the hole. As a result of that, we don't have uniform or cement around the casing, and this could lead to serious problems, especially when you're gonna start doing a frag job, because you might lose your frag liquid in this area. Cement plug. We have two types of cement plug. We have top plug, which is the black one. We have the bottom plug, which is the red one. The top plug, it has no hollow, it's solid. The bottom plug has hollow, it's empty. Under high pressure, it's gonna open up and allow cement to go through it. So we use the bottom plug to prevent any contamination between the cement and spacer and cement and the mud. And we use the top plug to prevent any contamination between the displacement of fluid and the cement. So by using those two plugs, we make sure that our cement is not gonna change, the property of our cement is not gonna change as a result of any contamination with other liquid in the formation or in the casing. Cement head, as you can see here, we have the cement head where we keep the plug in it. This cement head is connected to the casing after we run the casing, and we bump the cement through the casing, and we bump the plug as well through the cement head. This is the manifold. As you can see here, we have here 3 valves. It's allow us to control where we should bump the cement. Do we need to bump it from this valve or the middle or the upper, based on what plug you're gonna bump. we have two type of casing for of cement head. One of them is high pressure, the other one is low pressure. High pressure can sustain till like 15,000 psi. Low pressure can sustain till 10,000 psi. We need to make sure before we go to the location that the cement head that we're gonna take with us is gonna be able to sustain or higher than the job pressure that we're gonna anticipate in the location. Now let's move on to the cement job process. Here I'm gonna talk in details how we bomb the cement. What is the process exactly? As you can see here at the first step of the cement job, it's mud circulation by rig pump. So if you are a cement engineer and you want to the location there, and the first thing you're gonna do, you're gonna go to the company man trailer and talk with him, and you're gonna ask him what's the stats of the rig, and he said probably we are conditioning the well. What does mean by conditioning the well? That's mean he's circulating the mud from inside of the casing to the annulus, as you will see here. So now we bumping or circulating the mud from the inside of the casing to the annulus. We do this, it's kind of rule of thumb, 1.5 annulus capacity. Why we do that? Why we need to run the mud or condition the well with the mud before we do cement job? For many reasons. The first one, which is the most important thing, is to keep the well in dynamic mode, not static. Because if we keep the well at static mode, the mud could change from liquid phase to jelly phase. Jelly. So it's going to be very hard for us whenever we start pumping the cement to displace the mud. So that's why we need to keep it like circulating. Another thing, we need to clean up the annulus here. As a result of the draining, we need to clean up the annulus with the mud and
Hello, Ahmed. Do we lost the connection?
oh no. Can you hear me now?
Yes, I hear you.
Okay, great.
So please
So
share your screen again back.
okay. Hmm.
Just go to share screens, green button at the bottom.
Yeah, I don't see it.
Okay, 1 second.
I see you only, but let me use your link again.
No, just wait. I can withdraw you as a co-host, and I return you back as a. You can check if this works or not.
I don't know what happened exactly. You are the host now.
Now you are a host.
Okay.
Try to share. Do you still have it or not?
No, I don't see it. I don't have the option to share anything. Dr. Ahmed?
Yes, I hear you.
So what's going on?
Okay, I don't know what is the problem. So okay, can you return me back to be the host? Because now you are the host, right? You still don't see the share screen button?
I don't see anything. I see only you.
Okay, so let me disconnect and return back to you, and and connect again and start the meeting from the beginning.
It's weird.
Ahmed, now you are back, right? Okay.
Dr. Ahmed, can you hear me?
Yes, I hear you.
So, okay. Share screen. What's the screen sharing? I cannot share my screen. It's saying host disabled participant screen sharing.
Okay, 1 second, please. Okay, now you are a co-host, so now you can share your screen back again.
Okay.
You can continue. You just continue from where you stopped.
Yeah. So after we condition the well, we do pressure testing. The pressure testing here, we make sure after we rig up, what I mean by rig up, that we install all our equipment in location, which is from pump and cement equipment, bulk truck, field bins, and iron, and the cement head. We apply high pressure, around 10,000, 5,000, depending on what kind of job we are covering. And if we see, for example, if you can see here, sorry. You can see here, this is the gauge of the pressure. We apply pressure. If no decrease in the pressure, that means we don't have any leakage in our equipment. You can see here high pressure and no leakage or decrease in the pressure. That's indicate that we are good to start our cement and we don't have any leakage in our iron. After that, we pump a spacer ahead of cement. We have different type of spacer. We have freshwater spacer and chemical spacer. Usually we use like chemical spacer whenever we have a production job or critical job, where the spacer allow us to clean up the well bore diagram before we pump the cement. But for surface and intermediate, usually we pump freshwater. So after we pump the spacer, we drop the bottom plug. The bottom plug here, as you can see, this is the bottom plug. The bottom plug is used to prevent any contact or contamination between the mud spacer and the cement. We need always to keep the cement without any kind of contamination, because this is going to affect in the cement property. And after that, we start mixing the cement. As you can see here, here's the process of mixing the cement. This is the dry cement that we're going to get from the bulk truck or field bins. And here the source of the water that we're going to get from the location. You can see here now we're going to get the water. And after that, dry cement from here. And we start mixing the water with the dry cement and circulating inside the pump. till we reach the prospective density of the cement. And here we have cement mixed at the prospective density at the mixing tub inside the pump. And after that, we start pumping the cement. So pumping the lead slurry. As I mentioned, we have two types of cement, lead and tail. The lead has lower density compared with the tail. Lead is going to cover the upper part of the well. The tail is going to cover the bottom part of the well. This is the lead. After we finish mixing the lead, we move on to the tail. We start mixing the tail. As you can see here, the tail slurry is a higher density slurry for covering the shoe. So this is the tail, this is the lead, and this is the spacer. And after that, we drop the top plug, which is this one. So we open up the valve for the top plug. And after we finish, open up the valve to the drop the top plug, we start displacement. So in displacement, mainly we displace the cement from the inside of the casing to the annulus. And we have the top plug to prevent any contamination between the cement and displacement fluid. The type of displacement fluid, it's depends. Sometimes we use mud drilling, and sometimes we use fresh water, and sometimes we use brine water. It's depends on what kind of design that the company would like to use. But the majority of time we use fresh water. After that, after we finish displacement, we do something called check return. Check return, what we do exactly, we bleed the pressure from the well cement head, and then we observe how much of liquid we're gonna return, or we're gonna have returned at the surface at the pump. If we receive a lot of liquid, more than 3 to 5 barrels, that's mean we couldn't. That's mean we have a malfunction in the float collar. That's mean the valve that we have in the float collar did not suspend cement from going back to the casing. But if we receive 3 to 5 barrels only at the surface, that's mean we were able to achieve a successful cement job, and the float collar were able to hold the pressure and prevent cement from going back to the casing. This is like in general, like the cement job process and location from A to Z. Now let's move on to one of the most important topic, which is the cement lab testing. In cement, lab testing is very important for us because this is our indication about the cement that we're gonna pump in location. Here I'm gonna cover certain equipment in the lab. I'm not gonna cover all the equipment since we don't have that much of time. The first machine that I'm gonna cover is the mixing machine. Here we mix the cement. We simulate field mixing condition, which this machine is gonna simulate the pump in location when we start pumping the cement. We're gonna mix the cement at 4,000 RPM during 15 seconds, and then 12,000 RPM for 35 seconds. Here's the video. It's gonna show how we test the cement exactly. As you can see here, now we are weighting the cement volume in the lab. We're using electronic balance. This is the water. We usually grab the water from the location so we can mimic exactly what will happen in the location. You can see here the lab technician, he is very precise about the cement volume as well for water volume, because even small change in the cement volume could lead to a big difference. So you can see here now he's not focusing 185, he focusing the decimal here. So he looking for 185.15 or 16. After that, we're gonna move the cement and the water after we weight them to the mixing machine, where we're gonna mix it for 60 seconds, 15 seconds at low rate or and 35 seconds at high rate. By the way, this is not normal mixer. It's the ABI mixer that has been designed by American Petroleum Institute. So you cannot use mixer to do this job. After that, we filtered the cement to make sure to get rid all the solid if there is any salt exists or something like that. This is how it looks like cement after we mix it. It's homogeneous cement. And then we're gonna move on to the second part of the test. Uh, we have another machine here is conditioning to condition the cement. Here we try to mimic the slurry agitation while traveling to the pipe. As you can see here, this is how the video explain how we do it. In this machine, we try to mimic how the cement is gonna react while we're bombing the cement inside the casing and to the annulus. This machine can mimic the temperature of atmospheric and the temperature of the formation. And after that, we measure the rheology after we mimic around 30 minutes of bombing the cement inside the casing. And by measuring the rheology, you're going to be able to know the friction pressure. And this is the pressurized mud scale. I believe you're all familiar with it. We use it to measure the density of the cement in the lab and in location as well. Thickening time test. Thickening time test, it's the most important test in cement lab. By doing this test, we're going to be able to estimate the pumpability time. So it's the process to simulate pumping condition in order to determine a length of time before cement become difficult or impossible to pump. So by running this test, we're going to be able to know how much of time we have before cement set or before cement changing from liquid phase to solid phase. We measure the thickening time test by a machine called consistometer. The unit is burden unit. Usually, whenever the curve of the thickening time reaches 70 to 100 BC, that's the point that we estimate the thickening time. So here's the machine. This is the cylinder we use. We put it or install it inside the consistometer. These are the consistometer. And this is the result of the thickening time. As you can see here in x-axis, we have time, hour, and minute. And in y-axis, we have temperature, pressure, consistency. So the green curve here is representative the pressure of the formation. The red curve is representative the temperature of the formation. And the blue curve here is representative consistency. As you can see, at the beginning of the test, the consistency reading is around 11 to 10 BC. So this is giving indication that here still we have liquid cement. As soon as we reach 2 hours and 30 minutes, the cement is starting or the consistency starts going up, which means the cement is moving from liquid to solid phase. So to estimate the thickening time, we're going to see the reading at the 70 BC, where it intersects with the curve of the consistency, and then we read the time here. As you can see here, for this particular test, the bomb time or the thickening time, it's around 3 hours and 20 minutes. So from the result of the test, we can say this. We have 3 hours and 20 minutes to bomb the cement. if we have job need more than 3 hours and 20 minutes, that this cement recipe is not good for it. So we have only 3 hours and 20 minutes before the cement set. So before we bump any cement in any job in oil well, we need to run this test, whether in the pilot test or field blend test. Pilot test, it's a small portion of cement we mix in the lab, or field blend test. It's whenever we blend the whole cement volume that we need to deliver to the location, we get a small sample and send it to the lab and run it again and test it to make sure that we have enough pump time to pump the cement in the casing. By the way, this is very important test, because if you don't run this test, you might your cement might like sit while you're bumping the cement inside the casing. In this way, you might cost your company and the operator company around $4.5 million. So that's why this is very important test. And even whenever you go to location, the company man, drilling engineer, they're gonna ask the first thing about this test. So this is a video how we run the test at the lab. As you can see here, after we mix the cement, we put it in the cylinder, and you can see here they knocking around the cylinder just to get rid all the air bubble inside the cylinder, because this is gonna fit in the test. This is the consistometer machine. You can see here we're gonna download our cylinder inside the machine. And after that, we're gonna turn on the motor. As soon as we turn on the motor, the cylinder is gonna start rotating. This movement, it's mimic the condition of bumping cement inside the casing and inside the anode. And this machine is gonna sustain the temperature of the formation or reservoir and the pressure of the reservoir. So we try to mimic the whole condition of bumping cement in location. And then we start programming the machine there in the laptop. Another test we do, it's the free fluid test. Here we try to see how the cement is gonna react in a static condition, where we mix the cement in good condition in the bottom hole circulation temperature, and then we put it in a cylinder, 250 milligram cylinder, and keep it for 2 hours, and then observe if we're gonna have any separation between the water and cement, and if we're gonna have any free water at the top. We do it at 90 and 45 usually we prefer not to have any free water, because if you're gonna have free water at the top, this could affect in your frag job later, where you're gonna have connection, or you have communication between the fracs, plug and frac stages. So that's why in the production job, it's very, very important to have zero free fluid test or free water. Another test is viscometer here. The viscometer here, we measure the rheology of the cement at atmospheric temperature and the bottom hole circulation temperature. The main objective of doing that to see if the cement is mixable or not. If you have high reading here, for example, if you have instead of 2 and 3, you have 60 and 70, This is giving indication that the cement is not mixable. Uh, Another thing, if you have high reading for rheology, that's indication that you might anticipate or have high friction pressure while you're pumping the cement. So the viscometer here and rheology result help us to do simulation job for the cement before we pump it. The last test that I'm going to cover here about cement is going to be compressive strength. And the compressive strength is to determine how long it's going to take the cement to develop strength to support the casing or to start fracking. So the main concept behind this machine is to determine by measuring the change in velocity of ultrasonic signal that transmit through the cement. Whenever we have a solid cement, the velocity is going to be high and transit time is going to be low. Whenever we have liquid cement, the velocity is going to be low and transit time is going to be high. So from that concept, we have this chart. You can see here at the beginning of the test, here the green curve, it's representative the strength of the cement, and here is the representative the transit time. At the beginning of the test, we have liquid phase of cement, so the transit time is high. As soon as the cement start developing compressive strength, the transit time is go down because the velocity of the signal is fast now. So you may ask why we need this result, why you need compressive strength to know, for many reasons. For example, to know how long it's going to take to support the casing, the cement. Another thing, if the drilling engineer here would like to start drilling the next string, he would like to know for how long he should wait till the cement develop 500 psi of compressive strength. For example, if it's going to take 5 hours the cement to develop 500 psi, that's mean they need to wait 5 hours before they start drilling. Another thing, if they're going to do a frac job, they need to make sure that the cement achieve 2000 psi before they do frac job. So this is important result that you should send to the operator company or to the drilling engineer for every single job of cement. Mud and spacer compatibility test. Here we try to see how the spacer and the mud gonna react whenever they contact to each other. You remember when I mentioned that before we bump cement, we bump spacer to prevent any contamination or contact between the cement and the mud. By doing that, definitely we're gonna end up with contamination between the spacer and the mud. So we run the test to see how the contamination is gonna affect in our job. As you can see here, we run 100% of spacer, 0 mud, 75 spacer, 25 mud, and goes on. And after that, we see how gonna react or how the rheology is gonna be of the mixture. Is there gonna be any mixing problem or not? As you can see here in this picture, this is 50-50 of mud and spacer. And we have here mixing problem. If we have this in the annulus, definitely we're gonna plug the well. So we don't wanna see this. So that's why we need to do this test before a production job, which is the critical job every time. And these are the rheology reading. It shows us if we have any mixing problem. If we have high rheology reading, this means we're going to end up with a lot of problem while we're pumping the cement. Another rule of thumb that you need always familiar with, by the way, this is one of the question in the quiz, it's cement density. Cement density always need to be higher or equal to spacer density, and spacer density is always need to be higher than the mud density. You may ask why we need to have this, because after we bomb the cement, okay, and we start static mode in the annulus, we don't want to have a contamination between mud and the cement density. As a result of different density, we need to keep the density of the cement higher so we can keep cement and the bottom bar, we mud density lower so we can keep the mud at the upper part of the casing. So to keep separation between the different fluids. Cement additive, I'm not gonna go in details about cement additive here. So we have different type of cement. The majority of time here in the United States, we use class C and class H. Every type of cement has certain criteria, and every area in the world they're using different type of cement. But here in the United States, especially in Permian Basin, we use Class C for shallow depth. We use Class H for higher depth because Class H can uh, be solvate resistant at high pressure and high temperature, and Class C can create or have high strength development at shallow depth. Here we have different type of additive. As you know that we cannot pump cement only, because if we're gonna pump cement only, this is gonna affect, it's not gonna give us the right property that we're looking for. For example, accelerator. The accelerator here we add it to the cement whenever we need to reduce the pump time. For example, the pump time that we're looking for is 1 hour, and the pump time for neat cement or cement only, it's 3 hours and 30 minutes. So by adding accelerator, we're gonna reduce the pump time to 1 hour. Retarder, it's help us to extend the pump time. So it's opposite to accelerator. By adding retarder to the cement, we're gonna have enough pump time to displace the cement and set it in the right location in the annulus. And here another type of additive, for example, free water control. We add it to the cement to prevent the water, free water that I mentioned in the lab test. We add anti-settling additive. We have bonding agent. This is, we use it to improve the bonding between cement and the formation, and casing and the formation. Now let's move on to the bulk plant. Here the bulk plant is the area where we blend the cement. As you can see here, we have a silo where we store our cement. For example, if you have two types of cement, we're gonna keep Class C at the first silo, Class H at the second silo. If you have any other chemical, for example, fly ash, you're gonna keep it in the third silo. And here is the silo that we use to blend the cement. This is one of the techniques that we use to blend the cement, where we blow down the third of the cement volume, then first half of the additive, then the second third of the cement, then the second half of the additive, and then the third part of the cement. And then we're starting the we start starting blow down the cement from silo to another silo. It's called boxing. We start boxing the cement to just have homogeneous cement with the all additive. And then this is the spacer catcher, where we catch a sample for the whole cement while we blow down the cement to the truck that gonna deliver the cement to the location. And let's move on now to the cementing surface equipment. Here I'm going to talk about different type of cement equipment that we use. As you can see here, this is the pump that we use to pump the cement, which is the pump unit. Here is the displacement tank, and here is the, it's not clear exactly, it's the mixing tub where we mix the cement with the water. And here is the base maker, where we use it to pump the cement from the pump to downhole. This is another picture. It shows the displacement tank where we keep the water inside the pump. Here the base maker, which we use it to pump the cement to downhole. And here is the mixing tub inside the pump where we mix the cement with water. This is the bulk truck where we deliver the cement to the location. As you can see here, we use it to deliver the cement to the location. And this is the batch mixer where we mix our spacer, the spacer that we want before the cement. We mix it here if we have a chemical, if we have barite, and if we have surfactant, we all together, we mix it here, and then we pump it through the pump unit. This is how it looks like, the location of cement fleet or crew in oil rig. You can see here we have two pump here. You may ask why we need two pump. One of the main thing about cement job, we're not supposed to stop pumping at all under any kind of circumstances, unless it's safety problem. So if one of the pump went down, we can go to the backup pump and continue pumping. So this is kind of safety factor, so we don't stop pumping cement. And here is the field bins. It's another type of storage unit that we store our cement in location. You can see here we have 3 buds. Every bud has like cement. And here we have the bulk truck. The bulk truck as well, we use it to deliver cement, but for small volume, for high volume, we use field bins. And if you can see here, there is here pipe. This pipe is connected to the pump and go directly to the rig where we have cement head in the rig floor. So from the pump, we pump the cement through this small pipe to the rig floor, as you can see here. This is another picture for the location of cement job. This is the source of the water that we're going to use to mix the cement. It's called frac tank. Um, Usually, whenever we have a cement job, the first thing the cement engineer or cementer supervisor do is to make sure we have enough water. As well, he need to do quality check for the water to make sure that it's meet the requirement that we recommend as a company. And here you can see the supervisor truck and cement engineer truck next to the pump where they absorb and collect the data for the job. This is another picture. This is what I mentioned here about the pipe or the iron that we use to deliver the cement. So this is the pump. Here the iron is connected to the pump. We pump the cement through this iron, and this iron is go up to the rig floor and connected to the cement head on the casing. This is another picture, show how it looks like. You can see here's the field bins, and this is the hose that connected the dry cement to the pump. And here as well, bulk truck is connected to the pump unit, and this is the hose that connected. We deliver the dry cement through this hose to the pump. Here I'm gonna cover the plug cementing very quick, just to be familiar with it. So what is the plug? The plug, it's a certain volume of cement with high density that we pump in the well, whether it's for abandoned well or for web stacking to start kickoff point, or if you have low circulation zone while you're drilling, you lose all your mud. We pump the plug, and after we pump the plug, after the plug is set, we drill in it. So it has different purpose of the plug, but this is the most common purpose of pumping the plug. Squeeze cement as well. I'm not going to cover it in details. The squeeze cement, we do it whenever we have a problem with the casing. For example, we have corrosion in the casing. What we do, we bomb the cement through the corrosion to plug that area. Sometimes when we do cement job, the primary cement job, we don't reach the top of cement that we would like to have. So in this way, we we perforate the casing and start bumping the cement through the perforation just to increase the top of cement. And that's the end of the presentation. Uh, if you have any question, I will be more than happy to answer all your questions. I'm sorry if I took more time than I'm supposed to do, which is 7 minutes more.
Thank you so much for your presentation. And no, you did not take extra time. You're just on time. So we have around 100 questions. So I kind of picked out probably 5 questions to ask you. So let me start with the very first one. Can we rely only on solidification time instead of compression test results to decide when to resume drilling?
Can you repeat the question again?
Yes, sure. So can we rely only on the solidification time instead of compression test results to decide when to resume drilling activity or the drilling?
Usually the main way to know when you can resume drilling is the compressive strength. So this is like the normal way that we use here in oil and gas industry. So compressive strength is the most reliable way to know when you should continue drilling. So yeah, compressive strength is the main method. That's based on my experience, of course.
Okay, question number 2. How can we determine the number of joints in show track in different sizes of CSG to avoid wet show track?
Okay. Usually we like one joint to two joints. It's been in the very company kind of problem we had or design that you prepare. But and true, okay, that's why we do a short track. The short track area we're gonna keep the same.
Guys, it seems like we are facing a technical problem. The voice is not clear of both Engineer Ahmed Mansour and the voice of Nihal. Both are not clear. So we can, quit the session right now, and we can do a second video for questions and answers by Engineer Ahmed. Okay, so thank you very much for watching the webinar. And we will see you again after 1 hour for the second webinar of today. Thank you, Engineer Ahmed. Thank you.
Thank you, Dr. Ahmed. Thank you, Ahmed.